In this recording, I am going to talk about the reasoning agent in AG2 and also show a demonstration of the reasoning agent. Now, the reasoning agent in AG2, before I talk about the reasoning agent, right? So I want to talk about the thinker actor pattern. So this is a pattern that is getting popular where in a multi-agent system, you have a thinker agent or a planner agent that can plan uh, the most, um, I'd say, most relevant or the most efficient uh, plan to perform a certain complex task. It can break down the complex task into steps, which it can hand over to the worker or the actor agents to act on each of the tasks, and then it can aggregate and provide the result to the user. The concept of reasoning agent is similar. The reasoning agent acts as a thinker agent in that thinker actor pattern. Now, the strawberry series of models like the O1 models, O3 models by OpenAI, those are specifically trained to do reasoning. They are So although OpenAI does not reveal how they have trained them, but looks like those are trained using reinforcement learning by probably giving a lot of chain of thought examples to them, right? In AG2, the reasoning agent module or the reasoning agent logic has been implemented using tree of thought. Right? It actually is the reasoning agent is composed of two agents within that. We'll see that one is a thinker agent and one is a grader agent, and it supports three types of search strategies right now: beam search, then Monte Carlo tree search, and language agent tree search. We'll see the beam search, which is default. The way it works is, let's say I ask a question to the thinker. So as I mentioned, the reasoning agent has two sub-agents, the thinker agent and the grader agent, right? So let's say I ask a question to the thinker and the reasoning config, let's say I gave beam size of 2 and max depth of 3. How it will work is, so think about each layer of thought as one layer of depth, right? This is depth 1, depth 2, depth 3, right? So when I ask a question to the thinker, let's say I ask how many R's in strawberry, the thinker will create three, it will think about it, and um, let's say it has three thoughts, right? Thought 1, thought 2, thought 3. Thought 1 is um, one way of solving the answering the question. Thought 2 is a second way of answering the question. Thought 3 is a third way of answering the question. After these three steps or three thoughts are created by the thinker agent, the grader agent grades them in a scale of 1 to 10, right? And the beam size of 2 represents how many, which are the top two thoughts or the top k thoughts I need to take based on the beam size. So let's say the grader grades this two, the thought 1 and the thought 3 as a top one. The thought number second gets the lowest rating. Then um, these two thoughts will be taken for the next depth, right? The thinker will again take this thought, again probably will have a single thought or more than one thought based on it. In this case, there are two thoughts, right, that came out of the first one. Similarly, for the other thought also, it broke down into two thoughts. One of the thought is the final thought, right? The other thought goes to the third layer of depth, right? The three, we said max depth is 3, where it further breaks down into two thought. And finally, like I said, this thought is the final thought. These two final thoughts are then are then taken by the reasoner agent to answer the question, which we said is, let's say, how many R's are in strawberry, right? Let's see the program to create it. So this is the program. So I created a reasoning agent. This is the built-in agent. This is the ready-to-use agent that is there in AG2, which takes a name, a LLM configuration, which is this configuration here, where I give the GPT-4 as a model, and the reasoning configuration. So here I said beam size as 1. So beam size 1 would probably do only depth first search. And I just asked this question to the community also to clarify that if I say beam size as 1, probably it does one thought at a time as a and goes like a DFS type of search, right? How it works, like if you go into the reasoning agent, you will see that it has the thinker. Let me show you the thinker prompt. This is the thinker prompt, tree of thought message, right? If you look at the tree of thought message, this is the prompt that goes to the thinker to create the multiple or think about the question and create multiple thoughts or multiple steps, right? Or multiple options. Right? So given a question and a list of previous steps, the trajectory of the plan, you generate at least 4 innovative options for the next step. The user would not answer you anything, right? And it provides an instructions of how to create those 4 options, right? And it gives an example also. These 4 options are then given to the, so let me go back to the reasoning agent. So so this is the tree of thought message. This is what the thinker uses to create the options. Once this is created, then actually it is given to the grader. Now the grader, if I go to, there is a function called rate node. Here you'll see the grader, how the grader prompt looks like, right? The grader gets a prompt. This is the prompt the grader gets. Please rate the thinking trajectory on a scale of 1 to 10, where 1 is the worst and um, 10 is the best, right? So yeah, so we can give a 1 to 10 or 1 to 5, right? A great thinking trajectory must advance the process of solving the problem. Additionally, a good trajectory should be appropriate in conversation, contain no inaccuracies, be free of any odd or irrelevant content. If the trajectory does not meet one of the above requirements, it is considered a bad response. Please provide your rating along with a brief explanation of your assessment, right? So this is what is being used by the grader, uh, the grader agent that we discussed here. The grader agent uses this prompt to grade that particular thought, right? So now this is the reasoning agent. Then this is my user proxy agent. And finally, I initiate the chat by doing user proxy.initiate chat, give the reasoner agent and the question. And the question that I'm asking is how many R we have in strawberry. Let me turn on verbose so that we can see option it creates. So if I run this now, you'll see that it will, okay. So yeah, how many are, so the thinker, it created option 4 options. The grader then actually graded each of the options and it took top 2 of those options. Again, uh, here, right? It took top 2 and then further created 4 options for each of the 2 um, top graded options before, which will be given again to the grader to grade it, right? And finally, the top 2 will go to the reasoner agent. And in this case, the reasoner agent actually uses a program finally, a Python program. Let me go down. So yeah, so finally, it uses, let's solve this problem in Python using a simple approach. It creates a program, executes it, and then gives answer as S3, right? So this is how the um, reasoner agent works. In this program, what I did is I returned the chat result from the initiate chat. Now the chat result, if you see, the chat result is nothing but the chat history, the summary is um, blank in this case, and the cost of this particular um, reasoning, right? So, and in this code, after I take the chat history, I loop over the dictionaries in the chat history and print out the role name and the content, right? So it starts from here, assistant. So here, right, it starts from here. Assistant, role is assistant, user proxy, asked how many R we have in strawberry. Then let's solve this problem using a simple approach, right? Then the assistant said, okay, the code execution succeeded. And finally got 3, terminate, right? And yeah, everything terminated. And this is the total cost of the uh, of creating this answer. Right? So that's all I wanted to show as part of the reasoning agent. Thank you.